Here we're going to be graphing quadratics. Okay, now all of the quadratic equations that we see today are going to be in what's called standard form. It looks like this. There's y equals, and there's a number times x squared. Sometimes this number is 1. For example, in this whole page, that number is 1, plus a number times x, plus a number. And sometimes these numbers are negative, and sometimes they're big, and sometimes they're small. Okay, but this is what they're going to look like. Now, we're going to graph these the same way that we graphed lines yesterday, which is we're going to find the x-intercepts and the y-intercept. Now, there's going to be two x-intercepts. And the reason is that the graphs of these are called parabolas, and they look like this. They have this U shape. Now, we're also going to see ones that are upside down parabolas, but not today. Today, all of our graphs are going to look just like this. They're going to have this shape. Sometimes they'll be a little narrower. Sometimes they'll be a little wider, but they're all going to have this basic shape. Okay? Now, the way to do this is actually the same. So when I want the x-intercept, I plug in 0 for y, and I solve for x, right? And then my answer, my x-intercept, always looks like a number for x, right? This is my x value, and then a 0 for y because I've plugged in 0 for y. Okay, and then for my y-intercept, I'm plugging in 0 for x and solving for y, and again, I always end up with 0 because I plugged in 0 for x, right? And then I end up with a number here for y because that's what I'm solving for. And just like you did yesterday with lines, I'm going to plot the intercepts. And now, instead of sketching a line like I did yesterday, I'm going to sketch the curve. Okay? This curve, the shape of this curve is called a parabola, and that's the shape that you're going to be sketching because that's the shape of any quadratic. For now, we're going to learn some variations, but for now, that is the shape of any quadratic. Okay? So, what does it look like to find the x-intercepts? Now, this is tricky. Okay? I'm going to tell you the y-intercept, super easy. We're going to do the hard one first. If I want the x-intercept of this, I'm going to plug in 0 for y. So I'm going to plug in 0 right here for y, and I'm going to have 0 equals all of this. Okay, now look, I'm going to write it just because this is how I'm more used to seeing equations. I'm going to put equals 0 on the right side. I want you to understand, that is just me plugging in 0 for y, right? This 0 equals all this junk is the same as all this junk equals 0. I just flip the equation, it doesn't matter. Now, how do I solve this equation for x? This is not so simple as just subtracting 15 from both sides like I've done in the past. Here's how we solve. This is called solving by factoring. This is called solving by factoring. Okay, so it starts with factoring, which you know how to do. Watch, I'm going to write equals 0. Then I'm going to ignore it. Okay, I'm going to factor this. I need two numbers that multiply to 15 and add to 8. Those two numbers are 5 and 3. Now, look what I have. This is a number. This number times this number equals 0. This number, whatever it is, times this number equals 0. Now, what do I know? I know that if I multiply a number times a number and it equals 0, that either this number or this number has to equal 0. So either this number, x plus 5, equals 0, or this number, x plus 3 equals 0. Okay, now what? Well, now I solve. I need to find out what the x value is. So here I get x equals negative 5. Here I get x equals negative 3. Now, that means I have two x-intercepts, right? This is, I'm a little tight on space here. This is the point negative 5, 0. This is the point negative 3, 0. Okay, these are points. These are points on the graph. Okay, now why does this work? Look, if I plugged in negative 5 here, that'd be negative 5 plus 5. That would be 0. That would make this equal 0. Now, it would make this equal negative 2, but it doesn't matter. 0 times negative 2 is 0. It doesn't matter what this number is. Once one of the numbers is 0, then these two numbers will multiply to equal 0. I'm going to plot these 2 points. Negative 5, 0 is here, and negative 3, 0 is here. Now, the y-intercept. The y-intercept is way easier. Look, y equals, look what I'm doing. I'm plugging in 0 for x. Okay, so that's, instead of x squared, I'm writing 0 squared. Instead of 8x, I'm writing 8 times 0. Okay, what's 0 squared? 0. What's 8 times 0? 0. What does y equal? 15. Okay, so this is the point, 0, 15. So the y-intercept is here, 0, 15. Okay, now I have 3 points. I'm going to draw my u. How can I draw a u that goes through these 3 points? Look. Like this, okay? It's not the prettiest u, but there it is. Okay, it's going to look something like that. Okay. Let's do one more. I'm going to set this up. Now look, the first thing I'm doing is I'm plugging in 0 for y. So I'm taking this y and I'm making it a 0. So instead of x squared minus 4x minus 45 equaling y, it equals 0. Okay, so now I'm going to factor this. Okay, and look what I'm going to do. I'm going to put it up a little closer so I have a little bit more space below. I'm going to factor. I need two numbers that multiply to negative 45 and add to negative 4. So right away I realize, oh, I have a negative, so it's going to be a negative times a positive. And I'm thinking in my head, what are two numbers that multiply to 45? And when I subtract them, I get 4. And the numbers are 9 and 5. And I want to have more negatives than positives, so I'm going to make the 9 negative and the 5 positive. Once again, I have a number times a number equals 0. So either this number equals 0 or this number equals 0. Okay, now when I solve, I get x equals positive 9, right? That's this point where x is 9. And remember, y is 0. I plugged in y is 0 right at the beginning of my process. Or x equals negative 5. So that means x could be negative 5 when y is 0. Okay, and those 2 points, here's 9, 0. I'll put it way at the end over here. Or in fact, I'm going to put it not too far. So there's 9, 0, and then negative 5 zeros over here. It's like a little closer to the axis, right? Like if this is 9 spaces, then 5 is right there. Now, what is my y-intercept? I'm plugging in 0 for x. And you might notice there's like a little bit of a shortcut here, right? 0 squared is 0. 4 times 0 is 0. Oops, sorry, there's no, shouldn't be an equal sign there. That's silly. Okay, so what does y equal? It equals negative 45. So that means my y-intercept is 0, negative 45. And that y-intercept is way, way down here, right? It's already all the way down here at negative 45, probably even lower, right? Like if this is 9, 45 is going to be like a little farther. But that's okay. We're just sketching for right now. Right? This point is 9, 0. This point is negative 5, 0. And this point is 0, negative 45. And my u looks like that. Now notice right here, the u, like both of the x-intercepts are on the same side, so the u kind of hit the y-intercept over here on the side of the u. Whereas here, we had one y-intercept on this side and one y-intercept on this side, look, because we had one positive and one negative. And so then the u hit that y-intercept more so in the middle of the u. Sometimes, basically, if this is positive, then it'll look like this. And if this is negative, you'll have one positive and one negative number, right, because of just the way that we factor, and it'll look more like this. All right, go ahead and try those out.